Hi, folks. This is the activity in the morning lab, and you're asked to find the stiffness of this structure when you apply a load on the top and deflects downward. This is like a bellwether spring, and you're asked to find its stiffness. So what we need to do is to apply an arbitrary force up here on that edge and find out how much this thing displaces down, and then take that force and divide it by the displacement, and you get a rough idea of what the actual stiffness of the structure is. When you look at this thing, I hope you realize that it has to be solved with a shell element. And also, you're asked to take a 40-degree sector because of here there are many planes of symmetry, and you can take any sector, and that's fine. But you're asked to do 40 degrees, okay? And also, the meshing to be done in the fancy mesher, advanced meshing tool. Okay, so let's go ahead and create it. Oh, by the way, when it comes to creating this surface, there are different ways of doing it. One possibility is to create a truncated cone, solid object, make a 40-degree sector out of it, and then extract the top face, side face. That's not the route that I'm going to take. I'm going to take a slanted line and then revolve it about the z-axis by 40 degrees to create the surface directly. Okay, so let's go ahead and do that. We start with the part file. All right, and then I'm going to take that vertical plane. I'm already in the wireframe and surface design, therefore we can create surfaces here. So we'll take a slanted line and put the dimensions there. The dimensions from there to there is 0.5. That's the top radius. 0.5. And the dimension from there to there is 0.75. And the height from that point to that axis is 0.3. That's your h in the statement of the problem. Okay, good. Exit, exit, and then revolve it. Here is revolve. On the surfaces, here is revolve. About the z-axis, but by 40 degrees. So I'll put down 40 here. Here, 40 degrees. Very good. So this is what we got. Now notice that there's a sketch here. I'll leave it there. I can hide it, or I'll leave it here to show you what happens when I leave it there. The other thing is that this edge, where I did my sketch, is in the, if you look at it in the YZ plane, and the other edge is not in any one of these three planes. Okay, so you have to create an axis system. While we're at it, let's go do that. Here's the axis system. The origin, I want it to be at that corner point, and I'm going to rotate this thing about the z-axis by 40 degrees, okay, so that this edge, which was nowhere, basically ends up in the YZ plane of this coordinate system. So put the cursor there, in here, where the x-axis is, sorry, z-axis is. You put it where the z-axis is. You want to rotate it, right-click, rotation, 40 degrees, and then say, okay. And now that edge that you see here, that back edge, is in the YZ plane of that system. Okay, let's apply material properties to this. So I think it's steel. Problem says it's steel. So we do it like that. I don't have to join this thing. You can join it, but you're not going to gain anything if this is a single surface, which doesn't require join. Now we're going to go to the if we do the fancy mesh, we're going to go to advanced meshing tool, static analysis that you want to do, and here is the surface mesh. See that surface mesh? This is the regular three-noded triangular mesh. This is surface mesh. You select that surface, and I put down a number here, 0.01. I'll make it 0.05. We see how the mesh looks like. If it's too big, we change it. Too small, again, we change it. And if the type is linear, fine, we can make it linear. We can make it parabolic. We make it parabolic. We say okay. And once this happens, then you're going to go to this tool. See that execution? This icon, see this icon? Mesh the part. Mesh the part. You click on it and then exit. Say okay. And then exit. Okay. Now, if you can't see the mesh, let's go actually, it is possible to display it here, but I'd rather go to the generative structure analysis, because the rest of the problem has to be done there. And there we are. And if you say right click mesh visualization, let's change the rendering here. There you get something like that. Okay, if it's too small, if it's too big or too small, you double click on this and you go back there and change the number. But that's okay. I'll leave it the way it is. All right, good. Now deactivate the mesh, because there's nothing we can do while this is in front of us. So let's start with the restraints. So this edge is in the global YZ plane. So I select the user-defined restraint, uncheck all of these. In the global direction, in the YZ plane, so no displacement in X, rotations opposite. And of course, this step edge. Now, if you cannot pick it, that's because, remember, you drew a line, that sketch is blocking this. You cannot take the edge, because this, you can see that actually, there's a white line here. Right click, hide it. Now you can select this edge. Okay, good, good. And now we're going to do the other one. By the way, while we're doing that, I may want to name these. If it helps you, name them. So I'll say global YZ plane. Very good. Now we're going to do again user defined. Uncheck all of these. For coordinate system, use user and select this access system 1. And for the support, we select that edge. Now in that user defined access system, this edge lies in the YZ plane also. So no translation in X, rotations. Okay, very good. And I'll call this thing a user X, also ZY plane. ZY plane. Okay, user ZY plane or YZ plane. We say okay. Now this bottom edge sits on the ground. It's not clamped. It's just it is allowed to kind of roll on this. So you click on it. I select this, and the choice. Let's go and choose global, and I'll call this thing global XY plane. So it does not go through it. It just stays on that surface. So it's going to be translation in direction Z is fixed. It cannot go up and down. And then we say okay. Now, on that top edge, I'm going to apply a force of 100 pounds. So we go to right there, you click on the distributed force on that top edge in the global direction, negative 100. I already put that thing in there. And you can see it actually is right here. You can see that. You see this? If it's bothering you, hide these guys. You can see it better. You can see that right there. Okay. But anyway, we say okay. The only thing we have not defined is the thickness of this. So you click on the 2D property, you select that, and you put down the proper thickness. And I think the proper thickness was 0.1. You were told that this is 0.1 inch. So we say okay and run it. If I don't get circular pattern of displacement or stress, means that there's something wrong. Okay. Because exactly taking a 40 degree sector means that this should be all circular because it goes all the way around. Let's look at the displacement right there. and we make it average ISO and material shading right here. If you don't get circular pattern, there's something wrong with what you have done. Now, here's what you have to do. You found the displacement, maximum displacement of that top edge is 0.00078. To find the stiffness, take the load, and the load is not 100. The load is 900, because it's 100 times 9 of them. This sector is 40 degrees. So there's 9 of them that goes around the top edge. So the force to cause this displacement is 9 times 100. So 9 times 100 divided by that number is going to give you the stiffness of this bell spring. All right, folks? Good luck.